like to introduce now Sam Flottmann. Sam is a research technician within agriculture and food from CSIRO with a Bachelor of Science in Horticulture and Viticulture. Sam joined CSIRO in 2010 as a technician working with canola in Kojonup. Since 2015, he's been the lead technician on a wheat architecture trial and have developed skills in digital agriculture. Recently, Sam began working on the new GRDC High Rainfall Zone project. So let's please welcome Sam.
I'm going to talk to you today about the High Rainfall Zone Canola trial that we've got running this year. So some of the research scientists that are also working on this project are Hepping Zane, Hensberger and Andrew Fletcher. Hepping has really done a lot of work in this area over the last 10 or so years. So I'll just start with a bit of background to the project. So it's a high rainfall zone canola farming systems project, and the objective is to support growers to increase yield and reduce the yield gap through a grower participation research approach. So as mentioned, this project is funded by GRDC, and the research we're doing is in collaboration with Deep and Far Australia. So the project started last year. We did 3 grower group workshops, and they were conducted in the WA high rainfall zone, and these are at Dandaragan, Green Range and Esperance. So from these workshops, the key issues raised were that canola grown in the high rainfall zone has a low harvest index and fails to convert the biomass into yield. So harvest index is the ratio of the harvested grain to total shoot dry matter. So there's no real point in growing a lot of biomass and having a really big canopy if you're not converting that biomass into grain. So how can growers manage canola architecture and especially height? We found that obviously with tall canola it can be prone to lodging and also causes problem when it comes to harvesting and stubble management. So also another issue is how to best manage nitrogen applications to reduce the plant height and increase harvest index. So pretty much the conclusions from these workshops are that agronomic management options are needed to control plant height and canopy size. So what are the options? Some of the things we thought we could use is to look at plant growth regulators, nitrogen management, genetics, so what varieties are you using, TT and Roundup Ready canola, and also what is the role of dual purpose cropping, i.e. grazing. So for this year, our trial was planted at Ben Webb's Quail property. It was seeded on the 1st of May. So we've got 2 separate trials out there. Our main trial has 6 different varieties and 3 different treatments, and I'll go through the treatments on the next slide. So these 6 varieties are split between 3 Roundup Ready and 3 TT varieties. And we've also got a smaller plant growth regulator trial, which is all GT53, and the 3 plant growth regulators that we are looking at. One is registered for the use in cereals, one for fruit trees, and one in cotton. So these are some of the treatments that we imposed on the trial. So we went with 2 different seeding densities, 20 and 40 plants per square metre. So 20 plants per square metre is trying to replicate what most growers would be seeding at. From our emergence counts, the plots that were seeded at was the aim to get 20 plants per square metre was pretty much spot on, and those planted at 40 plants per metre were finding about 33 plants per square metre. So the 6 varieties I've mentioned in the previous slide, we've got 4 different fertiliser treatments, so mainly varying the rates of nitrogen and sulphur, and I'll go through those as well. We also implemented a grazing treatment, and obviously the plant growth regulator trial. So this is just an overview of the 2 trials. This was taken in early August Up the top you can see the small plant growth regulator trial and the main trial here, and you can see where we've done the grazing as well. So the 4 different fertiliser treatments. So I've got 2 at 150 kilos of N plus 2 different sulphur rates, and 2 at 300 kilos of N, again with 2 different sulphur rates. So they were split applications, so they were applied at seeding, 6-leaf, stem elongation and flowering. So the aim was to both match what growers typically may use and also having a high input treatment to try and maximise the yield. And really our aim was for 5 tonnes per hectare. So canola has a high demand for sulphur, therefore we want to keep the ideal ratios of N to S. So as we increase the nitrogen, we needed to increase the sulphur. So the grazing treatment, as you can see in the photo, we've got 5 metres of the original plot that was mechanically grazed using whippersnippers, and our aim was to do this before the budding stage. Unfortunately, due to a few travel restrictions, we were a bit late and some of the plants had started to bud before we had a chance to do the grazing. So obviously with grazing, you're aiming to reduce the plant height and you're also going to be changing the flowering time. So this is a photo taken 19th of August. As you can see in the foreground, the plants, in the foreground is the area that was grazed and they were just starting to flower while the main plot is in full flower.
It'll be interesting to see with the change of flowering. We've just had a very soft spring and canola is so subject to heat stress. You know, if it's only starting to flower late, it's going to get caught with its pants down.
Yeah. So another photo taken a bit later, 24th of September, still flowering while the main plot has finished flowering. And I've got a final picture. So taken yesterday, just from the side on. So you can see nearly finished flowering. The main plot is a lot more mature. You can see the difference in the colour as well. So I'll talk a bit about the plant growth regulators. So the main aim of plant growth regulators is to reduce the biomass. Will wanted to use them to see if we could reduce plant height and make the canopy more compact. So this is the first year that we've used plant growth regulators, and just to note that none of these are registered for the use in canola, so it's just a trial to see what they can do. So the 3 PGRs were applied at budding, and half the plots received a second application at the beginning of flowering. They're all applied at the label rates, and also just to note that this trial is being replicated at Esperance by Deepend. So just a little video of the plant growth regulator trial, just to see if you can see any differences in the plant height. So as you can see, I saw that last plot there, showed a significant difference in plant height. So this photo taken on the 24th of September. On the left, you've got the control plot. So my colleague Adam Brown is standing in the trial. So Adam's 1.8 metres tall. On the right, you've got the serial PGR, which has had 2 different applications. And you can see the effect that the plant growth regulator has had in this case. So with the cotton PGR, you can see it's had no effect. And in fact, it actually looks a bit taller than the control. And again, with using the fruit tree PGR, it's had an effect in reducing the plant height. So what this shows is that depending on the PGR that you use, it can have the effect of reducing plant height. So with our plant growth regulator trial, at final harvest we'll select some individual plants and measure plant heights and internode branch lengths to assess if there is differences between the canopy, between the different treatments. All the plots will have hand harvest cuts taken, and those will determine yield and harvest index. So we'll be measuring total biomass and seed weight. And all plots will also be machine harvested to get a plot yield. So a few conclusions at this stage in proceedings. The plant growth regulators and grazing have the ability to manipulate plant heights and canopy size. It's hard to see nitrogen and density differences just looking at the trial at the moment, so we'll really have to wait for final harvest to see what the yield and harvest index differences are. So the trials will run for the next 2 years, so this will give us a chance to fine tune and introduce new treatments. So watch this space. So that's it for the talk. I just wanted to open it up to any questions and comments, and there's a few things I thought we could talk about.
I just have 2 questions.
Yeah.
With the plant growth regulators, have you noticed any change in pod size and seed development? Shorten the pods?
Yeah, pod size is something we'll look at final harvest as well. We haven't really done any measurements on it at this stage. This year, due to sort of the COVID and everything, we haven't been able to do our usual suite of measurements and stuff, so it's been a bit difficult.
That's right. And the second question was about harvesting your main trial, because you've got those grazed sections. Are you going to harvest directly at the parts that haven't been grazed and then just wait for the others to mature?
Yeah, that's right. And we'll probably take more hand cuts out of the grazed section because it is just that sort of smaller area.
Which PGR, which plant growth regulator are you talking about? Because there's 5 different types.
Mode of action, mate.
Yeah.
I mean, I'm not sure, so you'd have to sort of look up the different PGRs. I'm not an expert in PGRs and the mode of action. So.
Scott, are the seed companies doing any work about reducing the heights of their newer varieties coming out? You know?
I can't talk for the seed companies, I'm afraid.
It's definitely on the radar. Look, we're trying
There
to
seems to be a way to deal with that problem long term, big breeder.
Yeah, I mean certainly like different varieties are obviously going to have different height characteristics. And so that's why we've had our 6 different varieties and they're all got slightly different heights and stuff like that. So,
Actually, I was just going to make a comment. I think the breeders will already, whether it's by default or not, have lowered the plant height. I can remember when we first grew canola, I'm 6 foot, used to be a foot over my head.
Yeah.
Now, even the latest Roundup Ready we used this year is a foot shorter than it was last year on an equal season. So I think they're already, and the problem probably comes by default in yield. If it comes up trumps in yield, it's stop lodging, it's stopped all sorts of things. I reckon they've already knocked a couple of feet out. If you look at Stingray,
it's
now it looks crappy and yields like buggery.
Yeah.
And you've got other crops that are big tall crops won't yield, all showing no go. But I think the breeders are doing a great job of knocking some canopy height out.
Yeah.
You go to Canada, and you can walk on top of their 3.5, 4 ton canola, walk on it like a bloody mattress. It's only that high.
They would have used PGRs, more than likely. They would have used PGRs more than likely.
Oh, actually, I don't know whether they had or not. It's like that, just like a spongy mattress. You'd be that far off the ground, you know.
Yeah.
That's what we need.
So any other thoughts or comments or any other major issues that I haven't covered that growers want us to look at?
I suppose I just have a couple for Ben. Was this on a cereal?
No, that was a pasture. So there was better nitrogen there,
Yeah.
And
And
it was
what
pretty
would,
good pH, I think, from memory.
yeah, what would be like your typical sort of canola yields that you're achieving?
Oh, around at 2. You'd expect 2.5 out of that paddock, probably.
I reckon harvest index is one of the major issues because of moisture. Surely these big crops like this are using a whole lot of moisture coming out of their leaves, and that when we seem to be going into this less and less moisture. Yeah. And maturity because we've suddenly lost a month of growing season off the end.
Probably more for webbing. Sulphur on canola, you've got sulphur in your rotations on the road.
No, we put on